A very good morning to all my dear students. Welcome back to online IIT class. Today we are going to discuss about our synopsis 8. Topic is latent heat. What is latent heat? Whenever a substance undergoes a change in state, whenever from solid to liquid or liquid to gas, it absorbs some quantity of heat without any rise of temperature. This heat is called latent heat. The amount of heat needed to change the state of given substance without any change in its temperature is called latent heat. We know that the mass of the substance is more, the quantity of heat required is also more. So we know that the relation Q is directly proportional to M. Q is the heat, it is directly proportional to mass of the body. So Q is equals to M into L. M means mass of the body, Q is the heat, and L means latent heat. Latent heat of the substance, it is a constant. So here, units of latent heat. SI unit is joules per kg or joules into kg inverse. And its CGS units are calories per grams or calories gram inverse. First one, specific latent heat of fusion. It is a quantity of heat required to convert unit mass of substance from solid to liquid state without change of temperature is called specific latent heat of fusion. Types of latent heats. There are two kinds of specific latent heats. First one, specific latent heat of fusion, specific latent heat of vaporization. Example, latent heat of fusion of ice is 80 calories per grams. Means for 1 gram of ice at 0 degrees centigrade to convert to water at 0 degrees centigrade, amount of heat required is 80 calories. This is called specific latent heat of ice.
Consequences of latent heat of fusion of ice. Latent heat of fusion of ice is the amount of heat required to change a unit mass of ice at its melting point into liquid at the same temperature. Did you know that the latent heat of fusion affects our life to a great extent? Let us discuss about some of the consequences of latent heat of fusion of ice. The temperature becomes very low after a hailstorm. This is because every kilogram of ice absorbs 336 kilojoules of heat energy from the surroundings and melts. As a result, the weather becomes very cold. For the same reason, it becomes bitterly cold as soon as the snow starts melting in cold countries. The weather gets pleasant when freezing starts in cold countries. Every kilogram of water on freezing releases 336 kilojoules of heat. Thus, when freezing starts in cold countries, a very large amount of heat energy is released into the atmosphere, and this makes the weather pleasant. Snow on the mountains does not melt all at once. Ice or snow has a very high latent heat of fusion equal to 336 kilojoules per kilogram. To melt 1 kg of ice or snow on mountains, the required heat energy has to be absorbed from the sun. Therefore, snow on the mountains changes into water slowly as it absorbs heat from the sun. Water in lakes and ponds in cold countries does not freeze all at once. The water freezes slowly and thus saves the surroundings from freezing and makes the atmosphere moderate. Aquatic life can survive in the cold countries even if the temperature of the atmosphere is 0 degrees Celsius or below 0 degrees Celsius. This is because the water does not start freezing immediately. The water on the surface will freeze first when temperature goes below 0 degrees Celsius, but below the surface it is not frozen. The high latent heat of fusion of ice, along with the anomalous expansion of water, enables aquatic life to survive in cold countries. Soft and hard beverages are cooled by adding pieces of ice and not ice-cold water at 0 degrees Celsius. Ice cubes are added while serving soft and hard beverages, as 1 gram of ice absorbs 336 joules of heat energy from the beverage to melt into water at 0 degrees Celsius. Thus the beverage loses a good amount of heat and cools effectively when a small piece of ice is added to it. The same effect would not be noticed when an equal amount of water at 0 degrees Celsius is added to the beverage. Change of state and specific latent heat. Specific latent heat is the amount of heat energy required to change the state of a unit mass of a substance without change in temperature. The word latent means dormant or concealed. Let's perform an activity to find out why the heat energy required to bring about a change of state is called latent heat. Take some ice cubes in a beaker. Suspend a thermometer into the ice cubes and note its temperature. The temperature is 0 degrees centigrade. Heat the ice cubes. Record the temperature after every minute. Keep stirring the ice-water mixture constantly so that the temperature is uniform throughout. We observe that the thermometer reading remains constant at 0 degrees centigrade, though heat is being constantly supplied. The temperature remains constant till the ice completely melts to water at 0 degrees centigrade.
This situation is called latent heat of fusion. Second one, specific latent heat of vaporization. A substance is a quantity of heat required to convert unit mass of substance from liquid state to gaseous state without any change in its temperature is called specific latent heat of vaporization. The specific latent heat of vaporization of water is 540 calories per grams. Means for 1 gram of water at 100 degrees centigrade to convert to steam at 100 degrees centigrade. Here the heat required is 540 calories.
Continue heating water which is at 0 degrees centigrade. We observe that the temperature is increasing. Record the rise in temperature till the water starts boiling. Continue heating. The boiling water gets converted to steam. Observe that the thermometer reading remains constant at 100 degrees centigrade, which is the boiling point of water. That is, there is no change in temperature. This shows that the temperature remains constant whenever there is a change of state.
This situation is called specific latent heat of vaporization.
What happens to the energy supplied? The energy supplied is used to break the intermolecular force of attraction existing between the molecules, and therefore the thermometer does not register a rise in temperature whenever there is a change of state. Since the energy supplied is not recorded in the thermometer, the heat supplied is called latent heat.
Experiment. Take some water in beaker and start heating. The temperature of water rises till the water starts boiling. As soon as water starts boiling, its temperature remains constant, even if heating is continued. The temperature at which a liquid starts boiling is known as boiling point. Boiling point is a property of given liquid. In this situation, the liquid molecules escape from the surface of the liquid to become vapor is known as evaporation. In this situation, temperature is constant. Heat supplied to a liquid at boiling point is utilized by liquid molecules to turn into vapor form. Here, heat is constant. Means thermometer indicates 100 degrees centigrade constantly. This is the boiling point of water. The heat energy required by 1 kg of liquid to completely turn into vapor form is known as latent heat of vaporization. In this situation, temperature in thermometer indicates 100 degrees centigrade. The liquid molecules escape from surface of the liquid and move into vapor or gaseous state.
At the end of this session, you will be able to describe change of phases of matter, explain different phases of matter and transition between them, describe latent heat of fusion and latent heat of vaporization. Change of phases of matter. Nearly every substance exists as a solid, liquid or gaseous state. An ice cube turns into water when left out of the freezer. A vessel of water will turn into ice if it left in the freezer. And water boils out of a pot if it is heated for too long. Thus, when water is frozen, it solidifies to ice, and when heated for too long, it evaporates into steam. Ice, water, and steam are three phases of matter of the same substance, water. Explaining process involved in change of phases. Continuous supply of heat to a mass of ice converts it to liquid and then to steam. Mass of ice absorbs heat energy and melts into water. This change of state from solid ice to liquid water is termed as fusion. Water absorbs heat when heated for few minutes and vaporizes eventually. This change of state from water to steam is called vaporization. Vaporization of a matter is a process of phase transition from liquid to gaseous state. Furthermore, steam releases its heat and converts into water droplets when collected in a vessel. The process of transiting phase from steam into water is termed as condensation. Condensation is the change of physical state of matter from its gaseous phase into liquid phase. Temperature of the system remains constant during phase change. During phase change, temperature remains constant even though heat is absorbed or released by the substance. Let's illustrate this. When ice melts to water and changes to steam by heating. Place a thermometer in the vessel containing ice and gradually heat the vessel over a low flame. Temperature of the ice vessel remains constant at 0 degree Celsius till all ice has melted. In spite of supplying heat to ice, its temperature remains constant. This fixed temperature at which a solid ice cube melts to liquid water is called melting point. The fixed temperature starts rising after the ice in the vessel is melted to water. Rise of temperature level stops again at 100 degrees Celsius when water starts boiling. As water boils and vapors, the temperature level remains fixed at 100 degrees Celsius. This fixed temperature at which liquid boils and changes into steam is called boiling point. Explaining what latent heat is. Heat is continuously supplied to ice, but its temperature remains constant at 0 degrees Celsius till ice melts to water. Similarly, temperature of water remains fixed at its 100 degrees Celsius during its change of state of vapor, in spite of continuous supply of heat to it. This hidden heat supplied to water, which does not affect its temperature level at 0 degrees Celsius and 100 degrees Celsius respectively. During its phase transition, it's termed its latent heat. Latent heat is denoted by L. SI unit of latent heat is joules per kilogram. What happens to latent heat if it does not rise the temperature? In ice cubes, molecules are tightly bounded by strong forces and vibrate in their confined positions. The vibrations increases on heating and the molecules collide with each other and the space between the molecules increases. Consequently, ice melts to water by the continuous supply of latent heat by keeping its temperature constant at 0 degrees Celsius. The quantity of heat required to convert 1 kilogram of ice to water without changing its temperature is called latent heat of fusion of ice. Likewise, temperature of water remains constant at 100 degrees Celsius. When it boils and eventually vaporizes, irrespective of continuous supply of heat, as water can only reach a high point of 100 degrees Celsius. This latent heat supplied to water sets its molecules free by breaking their intermolecular bonds without affecting their vibrating speed. Consequently, water boils and converts into steam as its boiling point. The amount of heat required to change 1 kilogram of liquid water to vapor state at constant temperature is called its latent heat of vaporization. Importance of latent heat in real life. Food cooks faster in a closed pan compared to open pan. This is because lid of the pan does not allow its produced steam to escape. as latent heat of steam is higher than latent heat of equal amount of boiled water, steam gives out more heat to cook food inside the closed pan.